Windows Operating Systems Part 3, Maintaining Windows. In this nugget, we're going to take you to the next step in learning how to support a Windows operating system, that is, maintaining the OS after it is installed. Most Windows problems stem from poor maintenance. If you are a PC support technician responsible for the ongoing support of several computers, you can make your work easier and your users happier by setting up and executing a good maintenance plan for each computer you support. A well-maintained computer gives fewer problems and performs better than the one that is not maintained. Regular preventive maintenance can keep a Windows computer performing well for years, at least once a month. You need to verify critical Windows settings and clean up the hard drive. These skills are covered in this part of the slide. If you notice the system is slow as you do this maintenance, you need to dig deeper to optimize the Windows. Three Windows settings discussed here are critical for keeping the system protected from malware and hackers. Users sometimes change the settings without realizing the importance. Check the three settings, and if you find settings that are incorrect, take time to explain to the primary user of the computer, of course, how important these settings are. Here are the critical Windows settings you need to verify. Windows updates. Install any important Windows updates or service packs that are waiting to be installed and verify that the Windows update is configured to allow automatic updating. Check the antivirus software. To protect against malicious attack, you also need to verify that antivirus software is configured to scan the system regularly and that it is up to date. If you discover it is not scanning regularly, take the time to do a thorough scan for viruses. And lastly, network location setting. To secure the computer against attack from the network, check that the Windows 7 network location is set correctly. For best performance, Windows needs about 15% free space on the hard drive that it uses for defragmenting the drive, for burning CDs and DVDs, and for a variety of other tasks. So it's important to delete unneeded files occasionally. In addition, you can improve drive performance and free up space by defragmenting the drive, checking the drive for errors, compressing folders, and moving files and folders to other drives. Two types of hard drives are magnetic hard drive disk drives, or HDDs, which contain spinning platters, and solid-state drives, or SSDs, which contain flash memory. For magnetic hard drives, Windows 7 automatically defragments the drive once a week. To defragment is to rearrange fragments or parts of files on the drive so each file is stored on the drive in contiguous clusters. In a file system, a cluster is also called a file allocation unit. It is a group of whole sectors. The number of sectors in a cluster is fixed and is determined when the file system is first installed. A file is stored in whole clusters, and the unused space at the end of the last cluster, called slack, is wasted free space. As files are written and deleted from a drive, clusters are used, released, and used again. New files are written on the drive can be put in available clusters spread over the drive. Over time, the drive performance is affected when the moving read-write arm of the magnetic drive must move over many areas of the drive to collect all the fragments of a file. Defragmenting a drive rewrites files in contiguous clusters and improves drive performance because it takes a shorter period of time to find the file to upload to the memory and execute in the CPU. Next, to make sure the drive is healthy, you need to search for and repair file system errors. The error checking utility searches for bad sectors in a volume and recovers the data from them if possible. It then marks the sector as bad so that it will never be reused again. To free up some space on the hard drive, consider these tips. First, uninstall software you no longer use. Doing so will free up some space on the hard drive, and if the software loads a service or program during Windows Startup might see performance improvement. Second, move data off the drive. Consider moving home videos, movies, photos, and other data to an external hard drive or burning them to DVDs or CDs. Third, move programs off the drive. If your Windows volume needs more free space, you can uninstall a program and reinstall it on a second hard drive installed in the system. And fourth, use drive or folder compression. Windows offers drive and folder compression that can save hard drive space. However, it is not recommended that you compress the volume on which the Windows system is currently stored. Let's talk about virtual memory paging file. Windows uses a file called pagefile.sys in the same way it uses memory. This file is called the virtual memory and is used to enhance the amount of RAM in a system. Normally the file pagefile.sys is a hidden file stored in the root directory of drive C. To save space on drive C, you can move pagefile.sys to another partition on the same hard drive or to a different hard drive. But don't move it to a different hard drive unless you know the other hard drive is at least as fast as this drive. A backup is an extra copy of a data or software file that you can use if the original file becomes damaged or destroyed. Losing data due to system failure, a virus, file corruption, or some other problem really makes you appreciate the importance of having backups. With data and software, here's a good rule of thumb. If you cannot get along without it, back it up. The time to prepare for disaster is before it occurs. If you have not prepared, the damage from a disaster will most likely be greater than that if you had made and followed disaster recovery plans. Suppose the hard drive on your PC stopped working and you lost all its data. What would be the impact? Are you prepared for this to happen? The current slide offers decisions you need to make for your backup and recovery plans. Read about it and then apply. After you have a backup plan working, test the recovery plan. In addition, you need to occasionally test the recovery plan to make sure all is still working as you expected. Do the following. Test the recovery process. Erase a file on the hard drive and use the recovery process procedures to verify that you can recreate the file from the backup. This verifies that the backup medium works, that the recovery software is effective, and that you know how to use it. After you're convinced that the recovery works, document how to perform it. Keep backups in a safe place and routinely test them. Don't leave backup disks lying around for someone to steal. Using Windows 7 Backup and Restore, you can back up user data and or the actual volume on which the Windows is installed. When you set up a backup schedule, you select the folders to back up, and you can also choose to back up the Windows volume. The backup of the Windows 7 volume is called the image, or the system image. A system image includes the entire drive C or other drive in which the system Windows is installed. When you restore a hard drive using the system image, everything on the volume is deleted and replaced with the system image. A system image must always be created on an internal or external hard drive. When using backup and restore to back up your data folders, you can include the system image in the backup procedure. Don't depend just on the system image as your backup. You should also back up individual folders that contain user data. You can create a system image anytime after Windows is installed, and then you can use this image to recover from a failed hard drive. Because data on a hard drive is likely to change often, it's important to back it up on a regular schedule. Using backup and restore, you can create a backup schedule that can include any folder on the hard drive and the system image. The folders and volume are first backed up entirely. That's called the full backup. Then on the second schedule or the next schedule you set, any file or folder is backed up that has changed or has been created since the last backup will be backed up. This is now called incremental backup. Occasionally, Windows does another full backup. If a file or folder later gets corrupted, you can recover the file or folder using the backup and restore window or using the previous version tab of the files or folders property box. A previous version of a file or folder is a version that was previously created by the backup and restore utility or by the system protection when it created a restore point for the system. You can use this point to restore a folder or file to a previous section or version. Windows System Protection Utility automatically backs up system files and stores them on the hard drive at regular intervals, and just before you install software or hardware. These snapshots of the system are called restore points and include Windows system files that have already changed since the last restore point was made. A restore point does not contain all user data, and you can manually create a restore point at any given time. Restore points are normally kept in the folder C:system, which is not really accessible to the user. Restore points are taken at least every 24 hours, and they can use up to 15% of your disk space. If disk space gets very low, restore points are no longer made. which is one more good reason to keep about 15% or more of the hard drive free. System restore restores the system to its condition at the time a restore point was made. If you restore the system to a previous restore point, user data on the hard drive will not be altered, but you can affect installed software and hardware, user settings, and OS configuration settings. When you use system restore to roll back the system to a restore point, any changes made to these settings after the restore point was created are already lost. Therefore, always use the most recent restore point that can fix the problem so that you can make the least intrusive changes to the system. System Restore is a great tool to try to fix a device that is not working, restore Windows settings that are giving problems, or solve problems with applications. Although it's a great tool in some situations, it does have its limitation. Keep these points in mind as you read on it. A hard drive is organized using sectors, partitions, volumes, and file systems. Here's how it all works. All data is stored on a hard drive in sectors, sometimes called records. Each sector on the drive is the same size, and for most hard drives, that size is 512 bytes. Sector markings used to organize the drive are done before it leaves the factory in a process called low-level formatting. The size of a sector and the total number of sectors on a drive determine the drive capacity. Today's drive capacities are measured in gigabytes, or roughly about a million bytes, or terabytes, roughly around 1 trillion bytes. A drive is further divided into one or more partitions. Windows can track up to 4 partitions on a drive. It keeps a map of these partitions in a partition table stored in the very first sector on the hard drive called the MBR, or the Master Boot Record. A drive can have 1, 2, or 3 primary partitions, also called volumes. The fourth partition is called an extended partition and can hold 1 or more volumes called logical drives. Figure 3-21 shows how a hard drive is divided into 3 primary partitions and 1 extended partition. Before a volume or logical drive can be used, it must be assigned a drive letter such as a C or a D and formatted using a file system. A file system is the overall structure an OS uses to name, store, and organize files on a drive. Windows 7 supports 3 types of file systems for hard drives: NTFS, FAT32, and exFAT. NTFS is the most reliable and secure and is used for the volume on which Windows is installed. Installing a drive letter, file system, and root directory to volume is called formatting the drive. It's also called a high-level format and can happen during Windows installation. One of the primary partitions can be designated the active partition, which is the bootable partition that startup BIOS turns to when searching for an operating to start up. Windows assigned 2 different functions to hard drive partitions holding the operating system, as you can see in figure 3-22. The system partition, normally drive C, is the active partition of the hard drive. This is the partition that contains the OS program to start up Windows. This boot program is called the OS Boot Manager or the bootloader. The other partition, called the boot partition, is the partition where the Windows operating system is stored. Here's a list of file systems supported by Windows that you can choose for volumes and drives that don't hold the Windows installation. You can read on from here. PC support technicians find it much faster to manipulate files and folders using commands in a command prompt window than when using Windows Explorer. In addition, in some troubleshooting situations, you have no other option but to use a command prompt window. To open the window, enter cmd.exe in the search box and press enter. Alternately, you can click Start, All Programs, Accessories, and Command Prompt. The command prompt window is shown here in figure 3-24. Windows 7 have 2 levels of command prompt windows, a standard window and an elevated window. The standard window is shown in figure 3-24 of your textbook. Notice in the figure that the default directory is the currently logged on users folder. Commands that require administrative privileges will not work from this standard command prompt window. To get an elevated command prompt window, click Start, All Programs, Accessories, and right-click Command Prompt. Then select Run as Administrator from the shortcut window. Now let's look at the file naming conventions you will need to follow when creating files. Wildcard characters you can use in command lines, and several commands useful for managing files and folders. When using the command prompt window to create a file, keep in mind that file name and file extension characters can be letters A through Z and numbers 0 through 9, and special characters, sometimes called funny characters, emphasized currently in the slide. In a command prompt window, if a path or file name has spaces in it, it is sometimes necessary to enclose the path or file name in double quotation marks. Let's look into some of the commands available to manage files and folders. You can always use the help command to get help about any command. You can enter help followed by the command name or enter the command name followed by a /? Table 3-1 lists some sample applications of this command. Use the dir command, short for directory, to list files and directories. In Microsoft documentation about command, also called the command syntax, the brackets in a command line indicate the parameter is optional. In addition, the parameter included in the greater than, less than, such as the file name, indicates that you can substitute any file name in the command. This file name can include a path or file extension. Table 3-2 lists some examples of the dir command. The md command creates a subdirectory under a directory, while a cd command, which is change directory, changes the current default directory. You enter cd followed by the drive, just like an md, and the entire path that you want to be. The rd command removes the directory, which is the opposite of the md command, which is make directory. Unless you use the /switch in an rd command, three things must be true before you can use this rd command. The directory must contain no files. The directory must contain no subdirectories, and the directory must not be the current directory. The del or erase command erases files or groups of files. The ren command, short for rename, renames a file. The file name 1 can include the path to the file, but the file name 2 cannot. The copy command copies a single file or group of files. The original files are not altered. The drive, path, and file name of the source file immediately follow the copy command. The drive, path, and file name of the destination file follow the source file name. If you do not specify the file name of the destination file, the OS assigns the file's original name to this copy. If you omit the drive or path of the source or the destination, then the OS uses the current default drive and path. Use the recover command to attempt to recover a file when parts of the file are corrupted. The command is best used from the Windows 7 recovery environment. The xcopy command, however, is a more powerful version of the copy command. It follows the same general command source destination format as the copy command, but it offers several more options. Table 3-3 shows some of these options. The robocopy, otherwise known as the robust file copy command, is not included in the Windows XP and is similar to the xcopy command. It offers more options than xcopy and is intended to replace really xcopy. A few options for the robocopy are listed in Table 3-4. The check this command fixes file system errors and recovers data from bad sectors. Earlier in the chapter, you learned to check for errors using the Drive Properties box, which does so by launching the check this command. Recall that a file is stored on the hard drive as a group of clusters. The FAT, FAT32, and exFAT file systems use a file allocation table called FAT to keep a record of each cluster that belongs to a file. The NTFS file system uses a database to hold similar information called the master file table, or the MFT. In figure 3-27 here, you can see that each cell in the FAT represents one cluster and contains a pointer to the next cluster in the file. The defrag command examines a magnetic hard drive for fragmented files, that is, files written to a disk in a non-contiguous clusters, and rewrites these files to the drive in contiguous clusters. You use this command to optimize a hard drive's performance. Table 3-5 shows two examples of the command. Recall that it's not a good idea to defrag solid-state storage drives, such as the SSD, flash drive, or smart card. Remember, doing so can shorten the lifespan of this drive. You can format a hard drive or other storage device using disk management. In addition, you can use the format command from a command prompt window and from the Windows 7 recovery environment. This high-level format installs a file system on a device and erases all data on the volume. Table 3-6 lists various sample use for the format command. Use the shutdown command to shut down the local computer or a remote computer. You must be logged on with administrator account to use this command. By default, command gives a user a 30-second warning before shutdown. To shut down a remote computer on the network, you must have administrator account on that computer and be logged on to the local computer with that same account and password. Table 3-7 lists some shutdown commands variations. The primary tool for managing hard drives is the disk management. In the previous chapter, you learned how to install Windows on a new hard drive. This installation process initializes, partitions, and formats the drive. After Windows is installed, you can use disk management to install and manage drives. In this part of the slide, you will learn to use disk management to manage partitions on a drive, prepare a new drive for the first use, mount the drive, use Windows Dynamic Disk, and troubleshoot problems with a hard drive. Suppose you have installed Windows 7 on a hard drive and used all available space on the drive for one partition. Now you want to split the partition into two partitions so you can install Windows 10 on a dual boot installation with Windows 7. You can use disk management to shrink the original partition, which frees up some space for the new Windows 10 partition. When you install a new second hard drive in a computer, use disk management to prepare the drive for use. This happens in a two-step process. First, initializing the disk. When the disk is initialized, Windows identifies the disk as a basic disk. A basic disk is a single hard drive that works independently of the other hard drives. Windows also installs a partitioning system on the hard drive. You can either choose MBR or GPT. Recall that the MBR system can have up to 4 partitions, although one of them can be extended partitions with multiple logical drives. The GPT system or the GUID partition table can support up to 128 partitions and is recommended for drives larger than 2 terabytes. The GUID partition table system is more reliable, but it can only be used on a 64-bit operating systems on computers that have an EFI or a UEFI chip rather than a traditional BIOS chip. In this chapter, we focus on the MBR system alone, which is by far the most common. Step 2 is to create a volume and format it with a file system. To create a new volume on a disk, right-click on the unallocated space, select New Simple Volume from the shortcut menu, and follow the directions on screen to select the size of the volume, assign a drive letter, and the name to the volume, and select the file system. When the process is finished, the drive is formatted and ready to use. When you open Windows Explorer, you should see the new volume available for use in the system. A basic disk works independently of other hard drives, but a dynamic disk can work with other hard drives to hold data. Volumes stored on a dynamic disk are called dynamic volumes. Several dynamic disks can work together to collectively present a single dynamic volume to the system. When dynamic disks work together, data to configure each hard drive is stored in a disk management database that resides in the last 1 megabyte of storage space on each hard drive. Home editions of Windows do not support dynamic disks. You can use disk management to convert 2 or more basic disks to dynamic disks. Then you can use unallocated space on these disks to create a simple, spanned, or even striped volume. To convert a basic disk to dynamic disk, right-click the disk area and select Convert to Dynamic Disk from the current shortcut menu. Figure 3-37 manifests this one. From here, you right-click free space on the disk and select New Simple Volume, New Span Volume, or if you choose, New Stripe Volume option from the shortcut menu. If you were to use spanning or striping, as in Figure 3-37, you could make disk 1 and disk 2 dynamic disks that hold a single volume. The size of the volume would be the sum of the space on both hard drives. Now for some serious cautions about software RAID where you use Windows for spanning and striping. Microsoft itself warns that when Windows is used for software RAID, the risk of catastrophic failures increases and can lead, of course, to data loss. Microsoft suggests you only use Windows spanning or striping when you have no other option. In other words, spanning and striping in Windows aren't very safe. To expand the size of a volume, use a mounted drive or use a hardware RAID instead. I hope this has been informative for you, and I would like to thank you for viewing.